Welcome to Solving Equations. Today we're going to go through and figure out what does it mean to solve an equation, why is it a thing, and how do we do it. Now, solving equations, a lot of people think of as memorizing things, but it's not memorizing something. It's really just a logic process. So let me pose you this question. If I said, what number plus 5 is equal to 10? Well, you're going to pretty quickly be able to tell me that answer, right? You're going to be like, oh yeah, 5 plus 5 equals 10. Duh. But how do we write that in math? Well, we're going to write what number. And for right now, I'm just going to use a question mark. Plus 5 equals 10. Okay. Well, what if I had more than one thing that I wanted to ask? Like, what two numbers plus 5 can equal 10? So that there could be more than one answer. I could say, 1 plus 4 plus 5 gets me to 10. Or 2 plus 3 plus 5 gets me to 10. Well, that question mark isn't a very effective space holder anymore because I want to be able to reference multiple answers. So we're like, okay, so what else do we know in the world that could help us here? And we're like, wait a second, we're really good at the alphabet. And that, my friends, is when they said, let's put the alphabets into math. The terror, the horror. Actually, it's just a placeholder. It's those containers that you use whenever you are at home. Usually, it's like the Betty Crocker butter container or a Cool Whip container, and you're like, "Oh, this is a good container. I'm going to use it for leftovers." And so you end up with all these containers that you have that might have a label on them, but that's probably not what's in them. It's the same thing in math, only instead of having a nice Cool Whip container to put stuff in, we said, okay, we're going to use the letter A to represent that question mark and said a number plus 5 is equal to 10. Or if I wanted to do more than one number, and I wanted to make sure I said they can't be the same number, maybe I'd say something like A plus B plus 5 equals 10. And I just want to know what two numbers could satisfy that. Now, the important bit here is that the first equation that we have, this a plus 5 is equal to 10, there's only one solution. Or one answer. Because we think, okay, well, there's only one number I can add to 5 and get 10. It's 5. Duh. But when we start with that a plus b plus 5 equals 10, well, now we have more than one solution. And the reason we have more than one solution is because we have more than one variable. Oh, variable. Ha. Let me just turn that math word here into what we're used to. You see these letters? These letters we got going on here? Yeah, we can't call them letters in math. That's too complicated. We got to call them variables, right? So we call these letters that act as our Cool Whip containers of the world variables. Variables. Okay, because guess what? They're variable based off of what container we're holding, right? If I'm holding the Betty Crocker container, I got maybe, some corn in there. And if I'm holding the Cool Whip container, maybe I got cranberry whip in there. You never know. So they vary what's inside. Therefore, we call them variables. Yes, very, very interesting in the math land, I know. But again, yes, when we have more than one of these letters in the equation, these variables, that means I'm going to have more than one solution. Unless I have a few more equations, but we'll get to that at a later time. So if we just start by using some logic, we said, okay, a number plus 5 equals 10. We said, okay, well, I know that number here, that number has to equal 5. But how could I mathematically get that using this equation, right? I'm thinking, okay, well, how could I turn a 5 and a 10 into a 5? Well, what did I do in my head? Maybe I said, okay, what number plus 5 equals 10? So I got 5, and then when I use my fingers, I'm going to go 6, 7, 8, 9, 10, and I had 5 fingers there. Maybe that's how I did it. Or maybe I said, well, if I do 10 minus 5, that's 5, so 5 plus 5 has to equal 10. Both of those are very viable ways to do this. And so what we find is that we can express what we're doing using that alternate operation. So if you didn't know, counting up using your fingers to get to 10, that is actually a way to do subtraction. Just like the person who said, well, 10 minus 5 is 5. So it doesn't matter if mental math is your thing or not, you can still get that answer pretty easily. But when it comes to my second equation there, where I have the two different variables, now we have something where my answer for B depends on what my answer for A is, or vice versa. So we're solving it, and there's more than one solution, so we use that same logic. We're like, okay, well, I can move that 5 so that I just have A and B, right? And I know that when I combine A plus B, it's got to equal 5. Why, might you ask? Because from the previous equation, I know that 5 plus 5 equals 10. So I know that this grouping of A and B has to give me 5. Well, now, what if I wanted to pick any number that I want for A and then get the corresponding number for B? Well, let's think about this. Just to write it out over here on the side, when we had this A plus 5 is equal to 10, we said there was two ways. I could use just some logic and say, well, 5 plus 5 equals 10. I know that. I've known that since first grade. That's something I'm good at. Or we could say, well, in this case, I know if I counted up 5, I'd get to 10. Or if I subtract 5, I get to 10. So I want you to think of this like a balance, like a scale. And a lot of people find it very helpful to put a nice little line down the middle. Here's my scale. Think the scales of justice. And right now, on this scale, I want to take 5 from the left and put it on the right. Well, if I take 5 away from one side, in order to keep the balance, I have to take 5 away from the other side. It's like having two kids. If you got twins, you better give them the same thing. Otherwise, somebody's going to be unhappy. Both of them are going to want the same toy. It's going to end up badly. So no matter what, you do the same thing for both sides. And how do you define side? Well, the side is where the equal sign is. So where I drew that line, that's how you know where the sides are. But in order to be able to do that, we have to look for things that can go together. So what you'll notice here is I lined up this 5 with the other 5. And on the other side, I lined up the 5 with the 10, or the negative 5, I should say. And the reason I did that is because those are something called like terms. All right, when we got two things that go together, those are like terms. And it just means that they have either the same letter, the same number, same exponent, and only likes can go with likes. Think of it like you're sorting a basket of fruit. If your basket of fruit's got apples, oranges, and bananas in it, and you want to sort that basket, you're not going to put an apple with an orange. You're going to put all the apples together, all the oranges together, all the bananas together, okay? They might all be fruits, but they are different fruits. So we want to separate them out, just to fulfill our CDO. And yes, that's the right order it's supposed to be in, not OCD. Whoever came up with that clearly doesn't understand the concept. All right, so if we take a look here now, we got A plus 5 equals 10. I'm subtracting 5 from both sides because, well, that's the opposite of adding. And I say, okay, well, what is 5 minus 5 equal to? Well, that's just 0. And 10 minus 5, that's equal to 5. I just bring down my equal sign. But there was something else up top that I had to bring down, and that's just this A. So I have A plus 0 is equal to 5. Well, what's any number plus 0? Does it change? So think about it. If I do 5 plus 0, 6 plus 0, 20 plus 0, 1 million plus 0, I still just got the same thing, right? So in this case, I don't really have to write that. So a lot of the times you'll see math people skip that step. And they'll just write that A is equal to 5. Well, that was pretty easy to solve, get my answer, call it a day, right? But it looks like a lot more when you start writing out all the things your brain's already doing. You knew at the beginning that 5 plus 5 equals 10. But now you know how to show and prove that 5 plus 5 has to be 10 using what you already know. So now let's go back over to our A plus B equals 5. Well, this one doesn't have numbers. So when I want to move something to the other side, again, I'm going to draw my little line down the middle here. Just so I have it, it makes it easier to reference and see what's going on. Do you have to do that? Definitely not. That is an option. And let's say I want to solve for A, because that's usually how they're going to write that direction. They're going to say something like solve for A. And if I want to solve for A, I'm going to use the same process I did on the left. I'm going to say, okay, well, I'm adding B. And I think to myself, okay, well, what's the opposite of adding a number? Well, subtracting that number, right? And if I subtract b from one side, you have to always do it to the other. It's my twins. If I don't do the same thing, we got a problem. But, uh-oh, I have like terms here. I have b and b. But when I go to the other side, when I look at the green here, those aren't like terms. I can't color code the 5 and the b the same color. They're not the same. They're not the same letter. Okay? If they're not the same letter, ew, I don't want you. Stay away. Right? So here's the deal. When that happens, yes, on the left-hand side, I can be like, oh yeah, I got this. B minus B, anything minus itself. Well, that just equals 0. So I got A plus 0 on the left again. But on the right, I have a 5 and I have a B. And they're not the same. They're not the same fruit. That is an apple and an orange. I cannot put them together. Or maybe I should say a kiwi and a banana because of the colors I use. But still, I cannot put those together. So what I have to do is just write it out and say 5 minus b because I can't do anything else with it. And what we've just found now is that a has to be equal to 5 minus b. And that's the whole answer because it completely depends on what number I choose for a, what I'm going to get for b. Now, I could have also solved for b there and gotten the answer, but I don't need to because it only said to solve for a. So on the left here, we have what we call solving an equation. And math people, we like to be fancy, so we have a name for the thing on the right here too. This is called solving a literal equation. Like literally, not even figuratively. Ha ha, but bad jokes galore. But this is the concept we're looking at. So this is not necessarily I'm going to memorize all the things that add to 10. This is I want to develop a process that gets me to the answer no matter what. And so when you think about it, you think about, okay, well, how do I solve that equation? By thinking, how do I undo what's happening to my variable? So let's go look at some other one-step equations. So if we look here at my first example, I have x minus 7 is equal to 8. So the first thing that I like to do when I get an equation, if I'm new to this and I struggle a little bit, I'm going to just highlight that variable because that's my goal. All right, so my first step is, what is the goal? All right, in this case, my goal is to get x by itself. All right, so the second question I do, or the second thing I look at is, what is happening to my goal? And I try to express that in words. So if I take a look here, I'm going to replace the x. Instead of saying x, I'm going to say a number because that's all this x represents. It represents some number. So a number minus 7 equals 8. Now you probably already know what number minus 7 equals 8. We're all pretty good at going through and adding and subtracting. Well, maybe on my part, not so much. But we go through and we're like, okay, a number minus 7 equals 8. Okay, well, let's think it through. Okay, so, well, if the number minus 7 equals 8, that must mean that the number is the same as 7 plus 8, right? So that's 15, I think, right? So I can think of it that way. Or I can write out my work. And this is especially helpful if that mental math component isn't as strong for you. Does it work either way? Most definitely. But this is really a helpful method to think of it when you're going through. So I just draw my line straight down and I say, okay, what is happening to my goal? Well, it's being subtracted by 7, right? My goal is subtracted by 7. So I say, how do I undo that? Well, what's the opposite of subtracting? Hopefully you're yelling at me that it's adding. So the opposite of subtract is to add. So if I add 7 to one side, I have to. Yep, saying it out loud. Say it to me. Say it to me. I want to hear that sweet music. Yes, add it to both sides. You know that that's what it is. All right, so we got plus 7 on both sides. Well, let's do that. 7 and 7 gives me 0. 8 plus 7 gives me, well, 9, 10, 11, 12, 13, 14, 15. 15, cool. And sometimes you got to use those fingers. That's perfectly fine to count it up with those fingers. So I now know that x plus 0 is equal to 15. Well, do I need to add that plus 0 there? Not really. It's not necessary. So I can just skip to that next step and say that x here has to be 15. And now what I'm going to do is check my work. I'm going to show that I'm correct. So what I like to do is I label that as check over on the side. I say, okay, if x minus 7 equals 8, I'm going to let x equal 15. All right, so that means that anywhere I see an x, I'm going to put a 15 there. Okay, let's do that. So I see an x, I'm going to put a 15 there, just substituting that 15 in. Anywhere I see an x, I'm subtracting 7, and I want to know, question mark, does that equal 8? All right, well, what is 15 take away 7? All right, 15, I need to use my toes for this one. So 14, 13, 12, 11, 10, 9, 8. All right, so I got 8 for that one. So I got that 8 here is equal to 8. Well, is that true? Is 8 the same as 8, even if I don't write them the same way? Well, yes, it is. And I can check my work and know that I've done the problem correctly. Now, this might seem like a little bit extra for this style of problem, but once you start getting into a harder problem, this gets a little bit more useful and seems a little bit less extra. So the same concept happens if I'm doing quote unquote a literal equation, right? Only instead of having numbers that I can put together, I have letters that I'm working with. So I look at this and I say, okay, I have x minus b equals a. I want to solve for x. Well, again, I highlight my goal. My goal is to solve for x, just so I know what's happening. And then I say, okay, well, what's happening to my goal? Well, currently what's happening to my goal here is I am taking away b. So I want to know, what's the opposite of take away? Well, that's just add, right? So if the opposite of take away is add, I'm going to do that. And if I do it to one side, I have to do it to the other. Well, are A and B the same letter? So I got my two B's. They can go together. Anything minus itself is just equal to 0. Cool. But can A and B go together? Are they allowed? No. No, they're not the same. They can't go together. I can't put two things that are different together, and I color code that wrong, so let me fix that color coding here. I can't put two things that are different together. It's not allowed. That's bad. That's no. Not allowed. Got to keep them separate, else they get in a fight. Okay? So what do I say for my answer then? Well, I just say that, well, since negative b plus b gives me 0, I have x plus 0 equal to, well, can't put them together, so I'm going to have to write them next to each other. A plus b, because they can't go together. And I know that anything plus 0 is just itself, so I get that x is equal to a plus b. And what I'm really doing here is rearranging the letters. Now, I can't solve this one, obviously, for a check. So we have to really rely on ourselves and our little method that we have here. So let's take our method down and look at another one. There's my steps here. And let's look at my second question. I have that 2a question here. It says 4x is equal to negative 12. All right, so what's my goal? Well, my goal here is to find x. So I highlight my x. All right. What is happening to my goal? All right, I'm going to try and express it in words. So it says 4x equals negative 12. So 4 times the number. So 4 times a number is negative 12. All right, So we want to figure out what number times 4 equals 12, and then what the opposite of that is, since it needs to be negative, right? So, okay, I'm looking at a multiplication chart. Maybe I'm thinking, okay, well, 4 times what equals 12? Okay, force table, drag it over. 4 times 3 is 12. Okay. So I know where my answer is going to be. It's either going to be a 3 or a negative 3, something like that, right? But, I told you, I'm not that great at times tables. So I'm going to think, okay, well, what is happening to my goal? It's being multiplied by 4. What's the opposite of multiply? Did you say divide? If so, you're right. So what we're going to do here is we're going to say that we have 4 times our goal, which is x, is equal to negative 12. And since we're multiplying by 4, all we're going to do to both sides is divide by 4. We're going to do the opposite. And remember, if I do it to one side, I have to do it to the other side. That's what keeps everything in balance. So I have 4x over 4, or divided by 4, and negative 12 divided by 4. So when I look at this, the first thing I'm going to see is that I have 4 divided by 4. Any number divided by itself is equal to 1. So I'm just going to put a 1 through that real quick, because any number divided by itself is equal to 1. And now I have 1x is equal to, all right, now I got to figure out how many times does 4 go into 12. All right, so I'm going to skip count by 4. So 4, 8, 12. That was 3. So I got 4 goes into 12 3 times. And since it was negative, the negative sign just gets brought down. So I got that 1x is equal to negative 3. Well, 1 times anything's just itself, isn't it? Like 1 times 10 is 10. 1 times 100 is 100. 1 times 5 billion kajillion is 5 billion kajillion. So do I really need to write that one? No, it's kind of like that 0 from before. I can just write x is equal to negative 3. Now, I want to check my answer. So what am I going to do? I'm going to go and I'm going to plug it back in. So I've got my check, and I affectionately call this a plug and chug. It's not the mathematical term, but it is what I like to call it. So I got 4x is equal to negative 12, and I want to let x equal negative 3 and see what happens. Now, from our last section, you know that when you plug something in, it has to be in parentheses. So I have 4 parentheses negative 3. And I want to know, question mark, does that equal negative 12? Okay. So I'm thinking, okay, I have 4 times negative 3. There's only one negative sign, so that's going to be negative when said and done. And that tells me that I'm going to count by negative 3 4 times. All right. So let's count by regular 3 instead of negative, because that's just too hard for me today. So 3, 6, 9, 12. All right, so 4 3s gets me to 12. And there was just one negative sign, so it's negative 12. All right. So is negative 12 equal to negative 12? Well, yes, it is. And that's a good thing, because that means that my answer is right. So I could turn this in right now and know that I'm correct. Now, of course, we're going to do the same thing, only with some just letters to see this process. So again, it's 3 steps. What's my goal? What's happening to my goal? And how do I undo that? So on this one, I'm solving for k. So my goal is k. I want k by itself. And I say, what's happening to my goal? Well, it says negative 3k equals m. What does that mean? It says I have negative 3 times some number, and it equals m. Well, I got to ask myself, how do I undo multiplying by negative 3? What's the opposite of multiply? Hopefully you said divide. Yes, so if the opposite of multiply is divide, and I always have to do the same thing to both sides, I say, okay, I got negative 3k divided by negative 3, and m divided by negative 3. All right, well, cool. So then I say, okay, well, let's get rid of what we can. Well, I know that any number divided by itself is just equal to 1. So if I have negative 3 divided by negative 3, that just gives me 1. And I'm left with 1k equals. Uh-oh. We got the same thing as last time. We got apples and oranges. We got things that can't go together, right? I got my negative 3's could divide because they're both numbers. But here, I got m divided by negative 3. I can't do that. That's not allowed. So guess what? You're done. You don't have to do any more work. You just write m divided by negative 3. Or if you want to get fancy, you can put the negative 3 on top. It doesn't really matter where it goes. So I could write negative m over 3, or I could write m over negative 3. Both of those are correct, and that's the whole answer. Do I really need that 1 there? No, so I can erase that. Okay, I didn't need it. It was just extra because I know 1k is the same as just a k. And it works out. That makes it a little bit easier. Now, of course, these start to get a little bit more complicated when you add in more steps. But those same things, those same 3 steps apply every time. And all you have to do is think, okay, so what's happening? Take that step and then rephrase it. So that's always my first tip for you, is rephrase it. So when I look at 3a here, I say, okay, well, what is my goal? What's my goal here? Well, my goal is to get the x by itself. So I highlight the x because that's my goal. All right, what's happening to my goal? First, I multiply my goal by 2. Then subtract 5. And I get 11. Now, I wrote it out this way for a specific reason. Because if I want to undo it, I have to go backwards. So I want to undo the last thing that they did before I undo the first thing. It's like when you're taking your clothes off. When you put your clothes on, right? You know, the first thing you put on is your underwear, then you put your pants on, then you put your socks on. Well, when you're getting undressed, you don't try and take your underwear off while you got your pants on, right? Because then, well, if your pants are still on and you're trying to take your underwear off, that's really hard to do. That's like a magic trick at this point, right? So instead of doing that, we start by taking our socks off, then we take our pants off, then you do your underwear, then you hop in the shower, whatever you're doing, right? But when we're looking at this here, we have to do that same idea. So if we started with multiplying by 2, then subtracting 5, I want to do that backwards. So the first thing I'm going to do, other than rewrite my equation so that I got some more space, is say, okay, well, I subtracted 5. What's the opposite of subtracting 5, right? Okay, well, opposite minus 5. Oh, that's just adding, right? The opposite of subtract is add. I say, okay, I'm going to add 5 to both sides. Because I know if I do it to one side, I better do it to the other. And since 5 minus 5 is just 0, I can do that. They're like terms. They can go together, right? Negative 5 and 5 gives me 0. 11 and 5 are like terms too, so they can go together. They're both just some numbers. And let's see, 11 plus 5, that's 16, right? So in this case, I get that 2x minus or plus 0 is equal to 16. Well, I don't really need that 0, so I'm just going to write it one more time and say that 2x equals 16. And again, I'm going to think, okay, so the first thing that happened was multiplied by 2. The second thing that happened was subtract 5. I did the opposite of subtracting 5, which means I add 5. So now I need to do the opposite of multiply by 2. Well, what's the opposite of multiply? Divide? Yeah. So that means the opposite of multiply by 2 is divide by 2. Okay. And if I do it to one side, I better do it to the other. Good. Because these are twins and they gotta like what they get. So I know that anything divided by itself is equal to 1. So I write a nice big 1 there. And I get that 1x, or just x, is equal to 16 divided by 2. All right. Well, I need to figure that out. No calculator. So I'm going to count by 2s until I get to 16. So 2, 4, 6, 8, 10, 12, 14, 16. I got 8 fingers up. So that must mean that 2 times 8 is equal to 16. All right. Now, I'm going to check my work, because I always check my work off to the side, by back substituting that back in. So 2x minus 5 is equal to 11. I'm going to let x equal 8 because that's what we got. So let's see if this works. 2 times 8 minus 5, question mark, does that actually equal 11? All right, so 2 times 8, what was that again? 2, 4, 6, 8, 10, 12, 14, 16. All right, so I got 16 minus 5 is equal to 11, or we want to know, does that equal 11? So now I need to take 5 away from 16. So use your toes again if you have to. But I know that 6 minus 5 is 1, so I get that 11. Does that equal 11? And guess what? Yes, it does. So yay, we did the problem right. And if it doesn't equal, you know you did something wrong somewhere. So it's nice because you can always know if you did it correctly. Now, when it comes to the same idea for a literal equation, we think the same way. If I had 2b minus 9 equals b, and my goal is to solve for b, I'm going to think, okay, well, there's my goal. What's happening to my goal? My goal here is being multiplied by 2 and take away 9. All right, so it's being multiplied by 2 and subtract 9. I want to do the opposite of those things. So we're going to start by undoing the minus 9, and the opposite of minus is what? Oh, add, that's right. So I'm going to add 9. All right, so let's do that. I add 9, because I know if I do it to one side, I better do it to the other, or else the twins are going to be unhappy, right? But wait, can I put D and 9 together? Are they like terms? No, I can't, can I? Well, gee whiz, I got things that aren't like terms. What do? Oh, that's right, I just write them out. It actually is easier. I got D plus 9, because I can't do it. And I just bring down my 2b here. So 2b plus 0 equals D plus 9. All right, I don't need that 0, so I'm just going to get rid of it and write 2b is equal to D plus 9. And then I say, okay, well, what's the second thing happening to my goal right now? My goal is still to get this b by itself. What's happening? Well, it's being multiplied by 2. Well, what's the opposite of multiply by 2? Hopefully you said divide by 2. And if I do it to one side, I better do it to the other. Now, this is where you can make an easy mistake, so careful. You have to divide the whole side by 2. The entire thing. All right, we can't just do one or the other. It's got to be the whole side divided by 2. Because I'm dividing the whole left, I got to divide the whole right. All right? Now, I know that any number divided by itself is just equal to 1. So I get 1b or b. And guess what? I can't do anything with that mess over on the right. So I'm just going to rewrite it. So d plus 9 and that whole thing divided by 2. And I'm going to call it a day because that's my whole answer. So sometimes it's easier that way when you think about it. Now, in 4 and 5 here, we just have multiplication and division going on. And the thing is, we've already done some with those. So I think I'm going to leave those for you to try out as exercise. But let's take a look at some of these equations down here that take a little bit more to do. So let me go get my little steps up here that we use. So what's my goal, what's happening to my goal, and how do I undo that? Those are my guiding questions as I try to go through and solve a problem. All right, ooh, there we go. So I look at this one and I say, okay, well, what's my goal again? All right, I'm looking, I'm like, okay, there's an X, I'm gonna solve for the X. Cool, that's my goal. Well, what's happening to that X is what I gotta ask, right? And I say, okay, well, this X here, it's saying that 14 is the same as multiply this number by 2 and add 26. So multiply by 2, add 26, and I get 14. And maybe I can logically think it through if I was really good at adding and subtracting. But I'm not really good at adding and subtracting, so I need to use some steps to help me get there. And so I'm going to think, okay, I want to undo that because what's happening, it's being multiplied and added. I want to undo it. So, well, what's the opposite of adding 26? Well, it's subtracting, right? I'm going to rewrite my question here, and I got 2x plus 26. And I'm going to say, okay, I know the opposite of adding 26 is subtract 26. And if I do it to one side, I better do it to the other. The twins will not be happy if I don't do the same thing for both. So I take a look here and I say, okay, well, 26 minus 26, that's 0. I don't really need to write that. But 14 minus 26, what is that? Gee whiz. You know what? I'm really struggling with that. I better write that down. So I'm going to think, okay, I know my answer is going to be negative because I have $14 and I lent somebody 26. So how much am I still needed? So I know the answer is going to be negative. So let's do 26 minus 14 to see what we get. 6 minus 4, okay, 6 fingers take away 2, I got 4. I'm sorry, 6 fingers take away 4, I got 2, there we go. And then we got 2 minus 1, which is 1, so I get 12. And specifically, I get negative 12 when I do that. It's equal to my 2x, and I don't need to write the 0, so I'm not gonna. All right, so I have done the opposite of adding, so I can cross that out. Now I need to undo multiplying by 2. Well, what's the opposite of multiply by 2? Well, that's divide, right? The opposite of multiply is divide, and I know that if I do it to one side, I better do it to the other. Yes. All right, and so I'm going to say, okay, well, 2 divided by 2, that's just 1. So I'm just left with an x, or 1x. And 12 divided by 2, or negative 12 divided by 2, let's skip count by 2's to find out. So 2, 4, 6, 8, 10, 12. I got 6 fingers up, so I know that the answer here, if I do 12 divided by 2, is 6. So negative 12 divided by 2 is negative 6. And again, I could go back and check my answer. So I go back and I say, okay, 14. Is that indeed equal to 2 times, what was my answer? Negative 6 plus 26. Okay, well, let's see. I know that 2 times 6 is 12, so 2 times negative 6 is negative 12 plus 26. And what is 26 minus 12? It's 14, right? Let's see. 26 minus 12. 6 minus 2 is 4. 2 minus 1, yeah, it's 14. Cool. So I get 14. Is that equal to 14? And yes, it is. So hey, we did it right. Awesome. And you'll notice that as we went here, I start skipping bits and pieces. That is definitely allowed. Once you start getting comfortable, you don't have to write everything out. So there's some things that you'll stop writing. For example, I'm going to probably stop writing this 0 that you see over here when I do my 26 minus 26 on both sides. Or I might stop putting the 1 through my 2 and my 2 to show that it's equal to 1x. Over on my check, I didn't label it check this time. And you'll notice that I didn't say let x equal negative 6. So sometimes we do end up starting to skip some steps as we get more comfortable with the material. So there's a couple more questions here that you can try out, see how you do. Please feel free to give them a try and ask questions if you have them. Let me know, and I hope this helps. Have a good one.